How is the temperature controlled during a TGA experiment, and why is it programmed in a controlled manner? What specific aspects of a material does TGA focus on in terms of thermal stability, and how does it help to evaluate the material's behavior under varying temperatures? Why is it important to study the thermal stability of materials, and what role does TGA play in understanding this property? How does TGA help researchers observe substantial mass changes in a specimen, and what can these changes tell us about the material's composition or structure? In what ways does TGA allow for the identification of different components within a material based on how they react to temperature changes? Can Davis Syrinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? What types of materials are typically analyzed using TGA, and why is this technique particularly useful for studying these types of substances? How do the mass changes observed in TGA experiments correlate with physical or chemical changes in the material, such as decomposition, evaporation, or loss of volatile components? What can TGA reveal about the decomposition temperature of a material, and why is this critical for understanding its thermal behavior and potential applications? How does TGA provide insights into the stability of a material over a range of temperatures, and what information does this provide about its performance in high-temperature environments? How do TGA data help in determining the presence of impurities, additives, or other components that might affect the material's overall thermal properties? How can the results from a TGA experiment be interpreted to understand the material's weight loss profile over time, and what can this profile indicate about its chemical makeup or structural integrity? What is the significance of measuring and analyzing mass changes in relation to temperature in the broader context of material science and engineering? How does TGA contribute to the development of new materials or the improvement of existing materials by providing detailed thermal stability information? What happens during the heat exposure process in thermogravimetric analysis, TGA, and how does this relate to the measurement of mass changes in a sample? What is the basic principle of TGA, and how does it work to convert the displacement of the balance caused by mass changes into electrical power? How does the electrical power generated during this process get amplified by an amplifier, and what role does the recorder play in recording these measurements? How is the magnitude of the power generated in TGA directly related to the amount of mass change in the sample, and why is this proportional relationship significant? When does the mass of the measured substance change during the heating process, and what are the specific physical or chemical events that lead to this change?